Hi, welcome to Turkish Engineering. In this lecture, we are going to take two more examples for projectile motion, and this will be the final video for projectile motion. Let's see what's the question here. So, a brick is thrown upward from the top of a building. So, I will just draw a building here. Okay. So, it will be just thrown from this height. Okay, I have a brick here, and it will be thrown by an angle with initial speed. So, the angle is just 20, the angle theta is just 25 degrees. And and the speed, the initial velocity is 15 meters per second. And the flight time is given. The flight time, T total, is 3 seconds. Okay, 3 seconds. So how can I solve this problem? It's asking for delta y. Actually, this one, how tall is the building? So it's asking for h, and actually this is delta y. Delta y. So actually, I know the time. So as you know, in delta y, we have v initial y times time minus just 4.9 times squared. This is our delta y formula, and this is coming from half of the acceleration in y. So I must know what is my initial velocity in y first. So how can I calculate this one? The initial velocity in y will be just initial velocity times sine of our angle. So initial velocity in y, initial velocity magnitude is 15. Actually, this is the initial speed times sine of 25 degrees. So we will see what's our initial velocity in the y-axis. So I will put 25 degrees. So I will get 6.34 meter per second. So I know the initial component of the velocity, which is this one, Vy. And so it's asking for how tall is the building. Actually, this one will go up, then we'll go down like this until it hits here, right? So I have a range for this problem, which is r, delta x max, and I have delta y. So from this point until I get here, the displacement in the y-axis will give me the height of the building. So I will just simply put our initial velocity in y, which is 6.34 meter per second. Then I will put my time, which is given 3 seconds. So then I will put minus 4.9 and t squared, which is just will be 3 squared. So let's see what's the height of the building. So put 6.34 multiplied by 3, then put minus 4.9 times 3 squared. It's just minus 25.1. Actually, as you see, it is minus sign. Why I got minus? Because as you see, the final point, which is just below the initial point. So I displaced in negative sign. I displaced downward. So I must get negative sign. If this, if it's asking about the displacement when I reach here, the highest point of the ball or the brick, so I will get positive delta y. But because of my final length, my final position for y, smaller than the initial position, so I must get negative sign here. So this is the answer of this question. And actually, let's zoom onto this one, t total. So it is 3 seconds. Can you say that t max equal to just 1.5 seconds? So just half of the t total. So when you reach here, your time will be 1.5. Can you say this? Actually, in this example, we cannot say. Why? Because actually t total 3 seconds will be just 2 times of what? 2 times of time, but the brick should start its point, actually its motion from this line when it hits the ground. This line when you just intersected with the ground. So if it starts to move from the ground level and then it will reach the ground level, so you will say that max T max will be just half of T total. But in this case, actually, you are starting to the motion by an initial height. So you cannot say that it's this T total, when you take half of it, it will give you T max. You cannot say it. But in this case, I can calculate for T max. So let's see what will be our T max result. So I will put T max. It will be just initial velocity in y divided by 9.8. Our initial velocity in y is just 6.34 divided by 9.8. I will get the time when it reached the highest point. So put your this one and this one, you will get the time. So it is 0.65 seconds. As you see, it is not half of the 3 seconds, because as I said, the motion started from an initial height, and it is not it didn't start to move from the ground level. But if it started from this point, the initial height was 0, so you can say that the half of the total time will give us the initial actually the time max, which is this one. So let's move to the next problem. Before we move, let me calculate the range. It is not asked here, but I will calculate it, okay? So I will put range, which is delta x max, will be equal to initial velocity in x multiplied by time, but time total. I must take the total time. Initial velocity in x will be just v cosine theta, and our total time is given, which is 3 seconds. So the range, which is delta x max, will be equal to our initial velocity is given in the question, which is 15 meters per second, and cosine of 25, because theta is equal to 25, multiplied by 3. So I will get here what is my range. 15 cosine 25 multiplied by 3 will give me 40.8 meters. That means the horizontal distance, which is from here to the last point, will be the range. So let's move to the last question. Here I have a fireman which is just pushing water to the fire in the building. So as you see here, the water started to move with an initial velocity, and I have a distance here, and I have angle theta, and I know actually it will ask for the h, which is the height of the floor, which is just firing now. So d, which is this one, 50 meters, will be equal to delta x. So let's put our known values. This will be just delta x, and it is just 50 meters. An initial angle for the velocity component is just 30 degrees. And initial speed, which is vi, is 40 meters per second. 40 meters per second. Actually, this is the magnitude, not the vector. This is just magnitude. So how can I calculate the h? Let's just take the initial components of the velocity. Initial velocity in the x will be just v cosine theta, which is v cosine 30. So 40 times cosine 30 will give me the initial velocity in x, which is 34.6. What about the initial velocity in y? It will be just v sine of theta, and actually the half of this one will give me sine of 30 will give me 1 over 2. So 1 over 2 multiplied by 40 will give me 20 meters per second. So what can I do now? I will start by putting the known one. So I can calculate for the time, which will be just time when you start from here until to reach there. So you can calculate the time by putting a known one. So this one is known. I will put delta x, which is equal to v initial x multiplied by time. So I can solve for time. Time will be equal to just delta x divided by v initial x. I know delta x, which is 50 meters, and initial velocity in x just 34.6 meters per second. So I will get result, meter will cancel each other, and 1 over second will flip up, so it will be just second. So 50 divided by 34.6 will give me the time, and our time is 1.45. 1.45 seconds. I rounded to 1.45. It's actually 1.445, so I rounded it to 1.45. It's our time, so I can calculate the h, because the h will be delta y when times equal to what? 1.45. I will put v initial y times time minus 4.9 t squared. Actually, minus 4.9 is coming from half of the acceleration in y, which is minus 9.8. So I will put delta y here, which is v initial in y, and it is 20 meters per second. Okay, just put 20, and time is calculated, so it's just this value. Then put your minus 4.9 multiplied by what? Just 1.45 squared. So I will get the answer. 20 multiplied by 1.45 minus 4.9 multiplied by 1.45 squared will give me 18.7 meters. As you see, I calculated the h, which is the height of the building, and it will be equal to 18.7. But in the previous question, I got a negative value for the delta y, but here I'm getting positive value. So what's the reason? As you see here, I started from an initial point which is in the ground, and I moved up. So my final point is bigger than the initial point. So I can say that our displacement in the positive way, it's upward. So when it will be upward, I can say that the sign will be positive. So this was the last question for projectile motion. So now we will just finish the projectile motion, and we will see in the next video. We will start by uniform motion, and that uniform circular motion. So uniform circular motion will be the last part of the chapter 3. See you in the next video.